Hello everyone, this is Mr. Minnick, and this is a video lesson for my Advanced Algebra 2A group. The pacing of this is going to go pretty fast, even faster than usual for this group. Um, we've got a pep assembly going on at school, so I decided to go ahead and pre-record this. I've got 36 minutes to go over about 90 minutes worth of material, so we better get started. Solving polynomial equations. So Chapter 5, Section 3, part of it's going to be graphing, part of it's going to be factoring. You will see a couple of new factoring concepts today. The National Common Core Content Standards, well, they're not national, but a lot of schools adopted them. You should be able to explain y coordinates of the points where the graphs of equations intersect are both solutions of the equation. So anyway, let's just get right to it. They're telling you that factoring can help you solve. They're reiterating what we had talked about yesterday or the other day. We said if B is a solution or a root or an x-intercept. Remember, solutions, roots, and x-intercepts all essentially are the same thing. Solutions refer to an equation. Roots and x-intercepts are referring to a function, okay? But if B is a solution, then x minus B is a factor, okay? We're going to use that idea again, okay? So in effect, we're just going to get stuff equal to 0. We're going to factor it, and the factors will in turn give us solutions or roots or x-intercepts or whatever we're asked to find, okay? So problem 1, I don't like when they call it problems because they're really not that bad. What we do want to do, there's a thing called the zero, not the 3x, not the 87, not the 451. It's the zero product property. The zero product property. Okay. Because of that, what we want to do with this equation in this first example is get everything equal to 0. So we'll have 2x cubed minus 5x squared minus 3x equals 0. At this point, you should clearly be able to identify and recognize that in our trinomial over here, there is a greatest common factor that every single term shares, and it's an x, so we'll factor that out. So we have x times the quantity 2x squared minus 5x minus 3 equals 0. As far as solving this particular equation goes, if we had a number like 6 out front or 2 or just a constant, we could discard it. However, this time we have a variable x out front, and that variable x out front, you have to be real careful not to discard it because that gives us one of 3 solutions we're going to have. We had mentioned the fundamental theorem of algebra. We should have 3 solutions, and one of them comes from that x out front. By the zero product property, if A times B equals 0, then either A equals 0 or B equals 0. Okay? But I'm not going to go ahead and find my answers just yet. I want to show the factored form. So when you do these, you should factor these out and kind of show the factored form until the end. It's just good practice too. Otherwise, you'll forget about something. So x times. Now at this point, if you wanted to guess and check, guessing and checking is terrific on this. There's nothing wrong with it. For sake of reviewing factoring by grouping, I am going to factor by grouping. I'm going to take 2 times 3. 2 times 3 is 6. 6's factors are 1 and 6 and 2 and 3. 2 and 3 are the ones that add up to be 5, but not, well, I got to look, that's negative. So no, it's not 2 and 3. I got to go with the 1 and 6. This is kind of weird, this factoring by grouping. What I'm going to have, the x is still there. My 2x is still there. My minus 3 is still there. Everything equals 0. What I'm going to do is I'm going to rewrite this negative 5x using the factors of 6 that subtract, and they have to subtract because of that 3 being negative. Means my signs and my numbers have to be different. So anyways, so that means I got to go with a 1 and a 6, and that's going to be an x. So an x and a 6x, and the 6x is going to be a negative right there. And then the other one is going to be a plus x right there. Okay. Is that going to get it done? You know what? That's not going to get it done. Huh. No, that's not it. Not going to go with that. Okay. And guessing and checking probably would have got us the answer faster. I'm sorry for the confusion on that one. So let's try this again. Factors of 6 are 1 and 6, and 2 and 3. I'm going to go ahead and go with the 2 and the 3. 2x, 3x, make these both minus, and that's going to factor by grouping. Remember how factoring by grouping works. What has to happen is that pair right there and that pair right there, each will have a GCF that gets factored out. Okay? So when we do that next step, the GCF that we could factor out of the first pair is 2x, which leaves behind x minus 1. And what should happen in factor by grouping, if you recall, it's been a while, but this binomial should appear again, and then will ultimately be one of the binomials in the end. Okay? So if we direct our attention to this right here, then we factor out a negative 3 out of that. So we factor out a negative 3, which leaves behind x minus 1. Surprise, surprise. All right, so x minus 1 is one of our binomials. The other binomial is, it's kind of weird what it is, but the other binomial is comprised of the stuff that we factored out. So our other binomial then is going to be 2x minus 3. Okay? So from all that, we can see that x equals 0, one solution. 2x minus 3 equals 0 gives us x equals 3 halves, a second of 3 solutions. X minus 1 equals 0 gives us that x equals 1, the third of our 3 solutions. Okay? More than one way to the Eastwood Mall. You're going to love this. Check this out. If we wanted to solve this, we could have by graphing it. I'm just taking a regular TI-84 graphing calculator. You could take a TI-83, you could take an Inspire, do the same thing. I'm taking 2x cubed minus 5x squared minus 3x, and I'm going to graph this with the standard viewing window. And what I want to see are the points where the graph goes through the x-axis. So I need to calculate the zeros of the graph. So I can see that one of my x-intercepts is negative a half. Hey, we had that, didn't we? Negative a half? No, we didn't. Hopefully I got everything in here, right? 2x squared minus 2x cubed minus 5x squared minus 3x. Is everything okay there? Hope everything's all right. I have a feeling that something went wrong with this particular problem. Have a feeling that something went wrong. Oh, no? No, nothing went wrong. 2x squared minus 5x squared minus 2x cubed minus 5x squared minus 3x. I factored an x out. Gave me 2x squared minus 5x minus 3, okay? Let me double check my factoring. Oh, I see. My factoring, something went wrong with my factoring, didn't it? Something went wrong with the factoring, and this is why factoring and being able to analyze this and knowing more than one way to solve is a good thing. I'm so glad this happened. It was an honest mistake. Remember the first time I was going to factor this a different way? Well, when I factored out that negative 3, I actually would have had an x plus 1 right there. So I got to back a lot of this up. Got to go back and redo a lot of this. Sorry for the confusion. Didn't mean to confuse you. And you'll be glad that there's more than one way to the Eastwood Mall when you see how easy this is another way. So let me try what I had started a minute ago. So I said, well, let's go with the x and the 6x. So plus x minus 6x. Okay, yeah, let's try that. So then we've got x times, and I'm going to factor an x out of that, so that'll be 2x plus 1. Okay, and then I factor out a minus 3, which leaves behind 2x plus 1. Hey, those are the same, yeah. So that's the right way I should have factored this. So I would have got x times x minus 3 times 2x plus 1. Okay, so I was right the first time I started that thing. I had been right. I was thinking right in the fact that we had a negative 3 here, and because of that, I had to have opposite signs. I had to have opposite signs on these two things right here. Okay. So going back then, x equals 0, x minus 3 equals 0, so x equals 3. And 2x plus 1 equals 0, so x equals negative a half, which confirms what the graph showed us, that one of the zeros is in fact negative a half. The other one, if we calculate a 0, choosing for the left bound, negative 2/10, and for the right bound, maybe 1. 0 is another 0, and then another 0 of the graph is 3. Okay, so the 3 zeros of the graph. If you want to see how to do that on an Inspire, no sweat. New document. On an Inspire, we're going to graph the same thing. Add graphs. Our function was 2x cubed minus 5x squared, and then minus 3x, I'm pretty sure. And I need to get rid of that little plus. Oh. It's going to be one of those days today. I could feel it. It's going to be one of those days today. F of x equals 2. Let's try this from the computer. 2. F of x equals 2x cubed minus 5x squared. And then minus 3x. On there, I hope it's pretty clear that the zeros are at negative a half, 0, and 3. Okay? So I'm glad I got that factored the right way. So I had factored it wrong. It's cool that you know, it's good that you know 2 or 3 different ways to solve these, because as you just saw, some things look like they might factor one way and in fact they don't. So I shouldn't show you this, but I'm going to. On my TI Inspire, I'm going to insert a calculator page. Notice I'm not using the scratch pad. I see a lot of you using that. The scratch pad's kind of limited in what it can do. Use the calculator pages. Save these pages somewhere so you can reference them later. Okay? That's a great thing about an Inspire. So if I go Menu, Algebra, Polynomial Tools, find the roots of a polynomial. The degree of that polynomial is 3. The roots are real. My a value, the coefficient of x cubed, was 2. My b value, the coefficient, or my next one, the coefficient of x squared is negative 5. The coefficient of x is negative 3. And the coefficient, or the constant, is 0. Watch this. Watch. How do you like that? It even gives them to you as fractions. Wow. Wow. So, okay. So we just saw problem 1. We can see that we're going to use ideas from chapter 4 with factoring. So we got to know how to factor. We should also be able to do these on a calculator by graphing, or if we're lucky enough to have a TI Inspire, we could find polyroots that way. If you have a TI-84, don't feel left out. There is an application. There's an application called polysimmalt. Yours might be polysimmalt too. If you don't have this, see me and I will make sure that you get this application. It basically does the same thing that the Inspire did. It'll find poly roots. The degree was 3, and our coefficients then were 2 and -5 and -3 and 0. Okay, and then we solve, and it doesn't give you the fraction, but you get the idea. It does still give you the zeros. Okay, so that's problem 1. I said we got a lot to cover, and we're about, well, we're a little less than halfway through. So I'm going to take this second and give a shout out to everyone in my advanced Algebra 2 class. I'd like to give a shout out to everyone who's been getting their homework in on time, and those of you who haven't, let's try to get it in on time, please and thank you. All right, so we've got 20 minutes to go over 45 minutes worth of stuff as usual. So here we go, let's get going. Hopefully we can factor the rest of these the right way. So part B, problem 1 still, example 1, 3x to the 4th minus 6x cubed. Remember, I got to put these in standard form. Minus 6x cubed plus 12x squared equals 0. It's real important, it's super important that you factor out the greatest common factor. The greatest common factor. In this case, that would be 3x squared, which leaves behind x squared minus 2x plus 4 equals 0. 3x squared minus 2x plus 4 equals 0. Now let's see what the directions said. What are the real or imaginary zeros of each? Ooh. Okay, I know that 3x squared equals 0, which tells me that 3 times x equals 0, which tells me x equals 0 twice, or with a multiplicity of 2. What that means is when I graph that polynomial function, the graph is going to appear quadratic near the origin. Okay? Well, now, I've got to solve this x squared minus 2x plus 4. I'm going to use completing the square, and you'll see something weird's going to happen. When I add -1 the quantity squared, I'm going to get imaginary roots then, okay? I'll get x minus 1 the quantity squared equals -3. So using completing the square, I take the square root, so I get x equals 1 plus or minus I rad 3, okay? So if I had to give a list of my zeros are these. They are 0 and 0 and 1 minus I rad 3 and 1 plus I rad 3. Okay, those are 4 of my zeros. Remember, there are 4 zeros because it's of degree 4. 2 of them were imaginary, and there's a total of 4, and 2 of them happened twice. That's kind of weird. Let's graph it and just verify that. Interesting thing about the imaginary zeros, they won't show up on the graph. Let me say that again. The imaginary zeros won't show up on the graph. 3x to the 4th plus 12x squared minus 6x cubed. That's not in the same order, but in the same form. So notice the graph is quadratic. Let me go ahead and zoom in at the origin. So the graph is quadratic looking at the origin as expected. The imaginary roots, the square root of 3 is like 1.7. So if I want to think about a decimal, 1 minus 1.7i is going to be negative 0.7i. And 1 plus 0.7i is going to be 1.7i. So when I do this on my TI Inspire or my 84, when I use that root finder, it's not going to give me the answer in the correct form, but if I know some square roots and approximations and some algebra, I can do this. So menu, algebra, polytools, complex roots. So I had, what did I have? 3x to the 4th minus 6x cubed, 3x to the 4th minus 6x cubed. Whoop, I got to get out of the exponent. minus 6x cubed, and then plus 12x squared. Plus 12x squared. So after I do that, I have to tell it, let's find the roots for the variable x. So I need to put a comma x in. Otherwise, the calculator won't like it. And here we go. It says 0. Notice it reiterates the 0. It says 0 is a 0, so a 0, and it does say 1 minus 1.7i. So, you know, when I simplified this, I simplified that wrong. That's horrible of me. Why would I do that? That's not cool. Why would I do that? You can't combine like terms. That part's real. That part's imaginary. Bad Mr. Minnick. Bad Mr. Minnick. You can't do that. So it's just 1 minus 1.7i and 1 plus 1.7i. Please, please, please don't use decimals. Please, please, please don't use decimals. Please don't use decimals. Okay. Got it. This is an extension of that first example. It says, what are the real or imaginary solutions? So x squared minus 1 times x squared plus 4 are our factors. So from that, we should realize quickly that we get plus or minus 1 and plus or minus 2i. If you don't see those that quickly, you might want to revisit factoring, because what we're going to do here in a second is really going to go much quicker than that. Okay, let's look at part B, because I have a feeling that some of you just feel like, whoa, I don't get it. This is way too fast. This is too crazy. Well, no, it's not. Minus 5x to the 4th plus 4x cubed. Oh, that's going to be plus 6x cubed, right? That's going to be plus 6x cubed equals 0. Factor out the greatest common factor. X cubed times x squared minus 5x plus 6 equals 0. So we get x cubed times x equals 0. We get minus 2, we get minus 3, so we get 0, 0, 0, 2, and 3. There we go. That one's cool. Let's try that on the Inspire. X to the 5th, and those should all be real. X to the 5th minus 5x to the 4th. So menu, algebra, polytools, find roots. 5th degree, 1x to the 5th minus 5x to the 4th plus 6x cubed, and then there was no x squareds, and then there were no x's, and then there were no constants, and okay, and okay, and bam, 0, 0, 0, 2, 3, like that. Okay? So you really need to be good at factoring. You really need to be fast and quick and sharp at factoring. So there's a new idea here called the factoring the sum and difference of cubes. The sum and difference of cubes. Let me write it real big. It says a cubed plus b cubed is a plus b times a squared minus ab plus b squared. That's called a sum of cubes. That's the rule. It will work. Follow it. I'll make some notes about it after you copy it down. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So what I want you to notice about both of these patterns, whether it's a sum or difference of cubes, and there is a rule for both, for sum and difference. With squares, it's just a difference of squares, okay? But for cubes, there's rules for sum and difference. I want you to notice each time it's a binomial times a trinomial. A binomial times a trinomial, okay? Real important to note, a binomial times a trinomial. Also important to note is the signs. The signs, okay? Let me highlight this. If it's a sum, the signs are plus, minus, plus. If we have a difference of cubes, if it's a minus, plus, plus. So each time there's two positive signs, and the binomial takes the sign of whether it's a minus or a plus. So if it's a plus, it's a plus. If it's a minus, it's a minus. You do enough of these and you just kind of get the idea of how they work, okay? So another thing that's worth pointing out is, well, how do I get to there? How do I get to there? How do I get to there? Well, to turn this a cubed into what has to happen in here, up first we take its cubed root. The cubed root of a cubed is what goes right there. Okay? The cubed root of a cubed is the first term in the binomial. Now, in the binomial, the cubed root of b cubed is the next term. The cubed root of b cubed is the next term. And you have to kind of forget about signs, S-I-G-N-S. You have to kind of forget about them and just trust that the pattern works. So when you're taking square roots and cube roots and stuff like that, or, well, cube roots, forget about the S-I-G-N-S, forget about the signs. The signs will be what the signs are based on the pattern. Once you establish the binomial, the trinomial comes from that. So to turn this a into an a squared, we square the first term. Okay? To turn this b into a b squared, we square that term. Okay? And then in the middle, this AB right here is the product of the two terms in the binomial. And again, you have to forget about signs. This AB in the middle is a result of the product of the terms in the binomial. Okay, so let's try one of these and let's see how it works. Number B, we've got x cubed equals 1. Well, that's not in the right form. We want x cubed minus 1 equals 0. So the pattern is that this is going to be a binomial times a trinomial. Okay? It's a minus, so it's a minus plus plus. Notice how I did that. I put those signs in. Those signs are going to be what the signs are going to be. Cube root of x cubed is x. Cube root of 1 is 1. X squared is x squared. 1 squared is 1. X times 1 is 1x. There we go. So this tells me x minus 1 is 0, which means x is 1. This tells me x squared plus x plus 1 is 0, which means x squared plus x equals negative 1, which means I need to complete the square. So I add a half squared, so I add a fourth. This is minus 4 fourths, so that's minus 3 fourths. That's x plus a half. The quantity squared equals that. If you don't know what I'm doing, go back, look over your chapter 4 notes, figure out how to solve by completing the square because you need to know it. So we get x plus a half equals the square root of negative 3 over the square root of 4. So we get x plus 1/2 is plus or minus I rad 3 over 2. So we get x equals 1/2 plus or minus I rad 3 over 2, or 1 plus or minus I rad 3 all over 2. You could have used the quadratic formula to solve that. Either way, quadratic equations. We just had chapter 4. We just had chapter 4 test. I'm assuming, I know what happens when I assume, but I'm assuming that you can solve quadratic equations, which means you have to be able to solve quadratic equations, which means if you're scratching your head saying, how did he do that? You need to go back to chapter 4 and look back over those notes. Okay? Don't want to sound mean about it, but you do. Part A here. This one's weird. This one's new. X to the 4th minus 3x squared equals 4. I like to think of this as a U substitution. There is a magic trick on these. It's not magic, it's just a little substitution. Okay? A U substitution. Let U equal x squared. Okay? What that's going to mean then is we've really got u squared minus 3u minus 4 equals 0. Wait a minute, Mr. Minnick, I don't understand what you just did. Okay, x to the 4th. Let's look at x to the 4th. X to the 4th is really x squared squared. And we said let u equal x squared, so that's u squared. Okay, so that's where my u squared came from. Then we said, well, let's let u take the place of x squared. So here was an x squared, so now it's a u. Okay. Oh, okay, that kind of makes sense now. Okay, so we can factor this. This is just a, yeah, I can factor that. That's a u minus 4 and u plus 1 equals 0. Oh, that's not bad. But wait a minute, it's not u, it's x squared. It's not u, it's x squared. So we have x squared minus 4 times x squared plus 1. So now I'm going to go straight to the zeros. If you don't see where they come from, again, I'm not saying I don't feel bad for you, but I am saying go back, look over the quadratic stuff. You really got to get this stuff now. If you don't, you're going to struggle. You're going to fall way behind. So we get plus or minus 2, and we get plus or minus I. Okay? So there we go. Those are the 4 zeros. That one's called a U substitution. Some people don't like those. Some people don't get those. Hopefully we'll have another example where that comes up. Okay? All right. So let's see. X to the 4th minus 16 equals 0. That could be x squared plus 4 and x squared minus 4, right? Equals 0. So that one will give us plus or minus 2i and plus or minus 2. 4 zeros, because it's quartic. Hopefully this stuff's starting to sink in. Number B here, x cubed plus 2x squared minus 8x equals 0. Factor out an x. That's x times x squared plus 2x minus 8 equals 0. That's x times x and x. Hey, 8 factors. Yeah, 2, 4 plus minus equals 0. So we get 0 and 2 and negative 4 for our zeros. Okay? Not doing any magic here. All I'm doing is just basic factoring. Factoring and then solving. Okay? Sorry that was so loud. Number C here, let's take a look at this one. We get x cubed plus 8x equals 8x plus 1. Oh. No, plus 8. I can distribute. Okay, so the 8x's cancel. So we get x cubed minus 8 equals 0. Oh, that's a difference of cubes. Binomial, minus because it's minus, plus equals 0. Cube root x cubed is x. Cube root 8 is 2. Got to know that. How'd you know that? Well, what times what is the same what each time is 8. 2 times 2 times 2 is 8. X squared is x squared. 2 squared is 4. 2 times x is 2x. What about the signs? The signs are what the signs are. Okay? So I know one of my zeros is 2 and the other ones are a mystery. X squared plus 2x equals negative 4. Let me try completing the square. Add 1 squared. Add 1. So this is going to be negative 1 plus or minus I. Add 3 for the other ones. Okay, how'd you get that? Well, let me fill in the blanks. X plus 1, quantity squared equals negative 3. Take the square root, take the square root. X plus 1 equals plus or minus I square root 3, and there you go. Okay, solving those quadratics, you got to be quick at those. You got to be quick. If you don't know how to complete the square quickly, get good at it. Practice, work on them. Okay. They're telling you now at this point, sometimes your answers aren't going to work out nice, and sometimes the only way to find these are to graph it on a calculator. So what they're kind of implying here is, you know what? The answers might not be integers. In other words, this might not factor. So you might have to use your calculator. I know some of you that scares you. Don't be scared. I said minus 4x squared, and then minus x. I said minus x. I wrote minus 4. So I'm graphing this. I see one of my zeros, and I see another one, and they're not integers. This is cubic. This thing turned around, and it's going back up. Let me do a standard window. On the left end, it's going down. On the right end, it's going up. Doesn't surprise me. I calculate a 0, choosing a left bound of negative 2 and a right bound of 0. My 1 0 here is negative 1.09. Approximately negative 1.09. Okay? I don't think that makes a fraction. X, make it a fraction. No. It's probably irrational. Okay? Let me calculate another 0. choosing a left bound of 0 and a right bound of 2. Our other 0 is 1.16. Approximately 1.16. That's not going to turn into a fraction. That one's irrational also. My third 0, if I choose a left bound of, say, 2 and a right bound of, let's say, 6, that probably ought to do it. And the other one's 3.93. There's some weird polynomials like that that aren't going to have any rational zeros. That happens from time to time, and you are going to have to use calculators to find some of them. Okay? So that's it. It's been real. It's been fun. If this went way too fast for you, look back over it and have fun at the pep rally. Good.